Hello learners, today we are going to study what is control system, what is the importance of study of control system, what are its various types, and what are the features of various types of the control systems. In this diagram, you can view a control system where driver wants to drive his car at a particular car speed. So what he is doing? He is increasing or decreasing pressure on the accelerator pedal so that the quantity of the fuel that is running to the engine of the car, that is increasing or decreasing, to increase or decrease the car speed. So the car speed is being measured with the help of the sensor and it is fed back towards the comparator. Here the person who is driving the car is working as a comparator. This comparator is being shown over here. This is the comparator that is comparing the desired speed with the measured speed and calculates the difference between the two. So the driver, depending upon having he is also being the comparator, he'll increase or decrease the pressure on the accelerator pedal by looking at the difference between the desired speed and the measured speed. In case desired speed is more and measured speed is less, then he'll increase the pressure on the accelerator pedal. Otherwise, he'll decrease the pressure on the accelerator pedal. And accordingly, the speed of the car will change and that will be appearing at the output side. And this process will continue till the actual car speed becomes equal to the desired car speed. So this is an example of the control system. So we can define that control system is the means by which any quantity of interest can be made to vary in accordance with the desired manner. So here, what is the quantity of interest? Quantity of interest is the car speed. We want to maintain the car speed at a particular value. Control system is found in each and every aspect of our life. Like when a person is moving straight on a road, that is also a control system. His nervous system is controlling him and that is making him to move in a particular direction. Then control system, since all of us are using ACs, refrigerators, there we are having automatic control system where we can control the humidity, we can control the temperature, and we can also sometimes control the total oxygen that is entering into a particular area. So there are a number of type of the control system, and the control system is present within our body, that is maintaining the temperature of the human being. Then we are having the control system within the industry to maintain the level, the liquid level, to maintain the pressure, to maintain the temperature, to maintain the humidity to a particular value, and then to keep the thickness of a particular thing or particular disk to a particular value. Then over there also we require a control system. So control system is everywhere, from our day-to-day life to big industries. So why do we require a control system? In case the process is not controlled, then there will be a lot of wastage. So when we are using the control system, that is done to improve productivity. Obviously, wastage will be reduced, productivity will be more, improve quality. Since we are we are making a particular quantity to vary in accordance with a desired manner. So it means that the output that is coming out of a process, that will be alike every time, because we are trying to keep the output at a particular value. Like in case we want to make up some disk of thickness 0.1 centimeter. So it means that in case there is no control, then obviously the output disk that will be available to us, they'll not be uniform in the quality. Some of them will be having a thickness of 0.1 centimeter, some may be having 0.11 centimeter. So when we are having a control system, it will help to maintain the quality or improve the quality that is coming out of a particular factory or a particular organization. Obviously, when wastages are less, quality is more, then we are going to get the economic benefits also. So, control system is an essential requirement. Then what are the components of a control system? So like we had taken the example of a car. So car was representing a plant, and this is the block diagram representation of a control system. So the plant is represented by this green block, GS. Then CS, this is the controller that is controlling the plant. The controller is getting the input ES. ES is the error. Error is the difference between the desired output RS and the actual output that is fed back towards the comparator through the feedback path. Then depending upon the input that the controller is receiving, it will be giving an output, or that is termed as the actuating input on the plant. So controller will be giving the input to the plant, that is the actuating input, and depending upon actuating input, it will be producing the output, that is the actual output of the plant, YS. So the controller will keep on giving the inputs to the plant so as to make up YS as equal to RS after certain iteration. So these are the components of the control system: the plant, then comparator, feedback element, and the controller. So there are a number of type of the controllers that we can have. We can have mechanical controller that are having only mechanical components, or we can have electrical controller which are having electrical components. These electrical controllers can be of analog type or the digital type. Since to nowadays we prefer using the digital component, the controllers using digital components because of the better quality, less cost, less space. So the digital controllers are generally used, and these can also be further classified into three categories. They can be microcontroller based controllers, or they can be computer based controller, or they can be programmable logic controller. These are the various types of the digital control. Then when we talk about the types of the control, then we can have two types of the control. First is the open loop control. Open loop means there is no feedback. In case we want the plant to produce a particular output, then the input to the plant is controlled with the help of the controller. So here we are having the controller that is shown with the help of the yellow block. Then we are having the plant that is shown with the help of the green block. RT is the desired output. So this is the basically the reference input, also called the desired output. Depending upon what we want as output from the plant, the controller will be giving the actuating signal UT to the plant so as to make up the output as equal to YT. Now this NT is representing what? It is representing noise entering into the plant. So it is, this overall block is representing a open loop type of the control system in which the system is working in the presence of the noise. So in open loop control, there is no feedback. Then the second type of the control system are the closed loop type of the control system. These are also called the feedback type of the control system. So what is there? Again, we are having a plant that is shown by the green block. Then noise is entering into the plant like this. Then the controller is giving the actuating input to the plant as it is giving in the case of the open loop type of the system. And the plant is giving the output as equal to y. But this output is sensed by the sensor and is fed back to the comparator in this way as shown over here. RT is the reference input or the desired output. Then from the sensor, the actual output is being fed back. Then we are having the error that is acting on the controller, and controller will be producing the actuating input to the plant to make up the actual output YT as equal to the desired output RT. Here RT is called the reference input also. So if we have a comparison of open loop and closed loop type of the systems, then we can very well see that there is no feedback present in the case of the open loop type of the system, and it is present in the closed loop type of the system. Then comes the second point of comparison, complexity. Since the number of components in the open loop control are less, so complexity will be less as compared to the closed loop type of the systems, where we are having the feedback path available with the feedback elements. As the number of the components are increasing in the closed loop type of the control, so it means that their complexity is more as compared to the open loop control. Then open loop control systems are less reliable. Like in this case, there is no feedback. The presence of feedback in the closed loop type of the system makes the output of the closed loop type of the system independent of the presence of noise, presence of disturbances, presence of aging effect, and all other practical aspects which may be present around the system. So they are more reliable, means they'll be giving you the desired output in all the circumstances. But open loop type of the controller, they are less reliable. Then open loop type of the controller are less accurate as compared to closed loop type of the system, because there is no feedback mechanisms in the open loop type of the control. In this case, in the open loop type of the control system, if you want to get the accurate output, then you have to improve the quality of the components that you are using to make up the system. And in case you want to improve the quality, then of course the cost of the system will increase. So we cannot make up the components more very much accurate in all the applications because of the cost criteria. So the open loop type of the control system come out to be less accurate as compared to the closed loop type of the control system. Then we can very well see, as we have seen these above 4 points, that closed loop type of the systems are better as compared to open loop type of the system. But there is one point where open loop control is better than the closed loop control. The open loop control system are more stable, or they are generally stable, and closed loop type of the control system are susceptible to being unstable in a number of circumstances, because within a few lectures, when we'll become familiar with the transfer function approach, then we'll come to know that how they will become unstable closed loop type of the control system. Actually, what do we mean by stability? The basic criteria for stability is that the system is producing bounded output for the bounded input. So open loop control will always give you bounded output for the bounded input, but closed loop control may not give you a bounded output always, because of the presence of the feedback elements. Then open loop control systems are not optimized, but closed loop control are optimized. Optimized in the sense that optimization means the best utilization of the resources. But in the case of the open loop type of the control, in case you want to get a very good output, then the quality of the components that you are using to make up the plant, that should be very superb. So open loop type of the control, in case you want to improve the quality of the component, the cost will become more. So they are not optimized. Means you are not making the best use of resources. Then open loop type of the control have the fast response as compared to the closed loop type of the control system. Their calibration is difficult as compared to closed loop type of the system. Then they are affected by the disturbances, obviously because there is no feedback mechanism, and closed loop type of the control systems are not affected by the disturbance. Now we have just come to know that in the case of the open loop type of the control system, we do not have any feedback mechanism which is present in the case of the closed loop type of the control system. And because of the feedback mechanism, closed loop type of the control system, they become superior as compared to the open loop type of the control system by becoming immune towards the presence of disturbances, noise, and other environmental factors. So, if we talk about the examples of both type of the control systems, then in the case of the open loop type of the system, we can have traffic light. Like there is no feedback. The traffic light that we used to have many years ago, like that we had learned in our nursery class, that this is red light. It will be on for a few seconds, then we'll be having a yellow light, then we'll be having a green light for a few seconds. Those traffic lights never used to take care of the traffic which was coming out from all the sides. So that conventional traffic light, they constitute the open loop control. They are just giving the input. Input is given to the red light for few seconds, then for yellow light, then to the green light. No feedback mechanism. Then we are having a washing machine. In the automatic washing machine, you just that we are using at our homes. Not I'm not talking about the modern washing machines in which there are fuzzy mechanism incorporated, or the modern controllers incorporated. So these automatic washing machines, just they are having a cycle. For a few minutes they'll wash, and then they will rinse, and then they will dry. So the overall program is fixed. It is not looking at the quality of the clothes produced out of washing. It is not taking out of the feedback from the output side. So it's an open loop control. Then when we talk about the closed loop control, then it can be a temperature controller that is being used in a refrigerator, or that is being used by an air conditioner that you are using. Like you have set your air conditioner to a temperature of 25°C. Then in case it becomes more than 25°C, then the cooling effect of AC will be increased, otherwise it will be decreased. So as to bring the temperature of the room back to 25°C. So it's a closed loop type of the system, means it is having a measure of the output temperature, that is the temperature of the room, with the help of the sensor, and depending upon the value of that temperature, the controller will take up the control action to make the temperature equal to the desired one. Then we are having a toaster. It will just look at the quality of the output that is being produced. So it's again a closed loop type of the system. So we are just having we are having a number of advantages of both type of the systems. So this is the basic way of classifying the control system. Main difference is simply the presence or absence of the feedback, and depending upon that, we are having a number of advantages of both type that I've tried to just make you learn within this lecture. So in the next lecture, we'll be learning about the classification of the control system on the basis of signal used, or on the basis of type of the system, and many more classification of the control system will be discussed by us. So thanks for patience learning. So now I am Stopping the recording.